Okay, guys, so I'm back. We did that multiplying. Remember again that this is our operations with rational expressions. Our objective is to simplify rational expressions using our basic operations, adding, subtracting, multiplying, and dividing. So we've done a basic simplifying, and then there's the multiplying, and now we're going into dividing. Again, this is with factoring that we do this. So I'm going to go ahead and get started with that. Let's start with our easy problem. All right, so we see here, we know that x squared, let me fix that a little bit, minus 25, that's a perfect square, and 25 is a perfect square, so we're going to use the difference, okay, of perfect squares. So let me come in a little bit on that. So we've got it's x minus the perfect square, 25 is of 5 being squared. So x minus 5, x plus 5, you see there. All right, here in our denominator, we're going to have to do a little bit of that factoring when a does not equal 1 and there is no GCF because 2, 5, negative 12 don't have that common factor. So let's take a look. We've got 2 and negative 12. That gives us negative 24. So factors of negative 24, that would give us a positive 5. Now, because it's negative, we know they're opposite signs. So there's 1, there's 24, there's 2, there's 12, there's 3, and 8. And ding, 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 I know 3 and 8 will give me a difference of positive 5. Now, for it to be a positive 5, that means that the 3 must be the negative. So 2, 12, 1, 24 don't work, but negative 3 and positive 8 do. So remember that our rule says that when we are having to do this type of factoring, that we take the first term, okay, without the square value, pop that over the first factor, and then again over the second factor. All right, so we got 2x over minus negative 3. That won't reduce anymore, but this 2x over 8 will, and I want you to see that it becomes x over 4. Okay, all right, so there we go. We've got those factors of that. I'll give you a little bit of color coding here so you can kind of see what happens. So that goes from being 2x squared plus 5x minus 12 to 2x minus 3. Okay, that 2x over negative 3. And then x plus 4, x over positive 4 that we've got there. All right, let's move this over, and we're going to take a look now at this numerator, x squared minus 3x minus 10. We know the factors of 10 are 1, 10, 2, 5, and that the 2, 5 will give us a negative 3. If we make that be, that is x minus the 5 and x plus the 2. Again, you could have switched those around, x plus 2, then x minus 5. You get the same answer either way. All right, so let's take a look now here at the denominator, and we've got to figure out what our factors of 20 that would give us a sum of 9. That's 1, 20, 2, 10, 4, and 5. 4 and 5 do work to give us 9. So that's x plus 4, x plus 5. Now, here's something really important we need to remember when we are dividing. Okay, I want you to see this is a division. Any type of fractions, they always follow the same rule. All right? Give me a new color here. We leave the first term just like it is. We don't do anything to it. We're going to change the division to a multiplying, and we've already done multiplying, so we know how to do that. But then we need to flip over this second term or get its reciprocal LCR. We've talked about that in class before. Nothing new with that. So we're going to rewrite it in its factored form using our LCR rule. All right, so let's move this over. Okay, so I have x minus 5, x plus 5 over 2x minus 3 and x plus 4 times now our x minus forgot. I got to flip that over. That's x plus 5 reciprocal. So we have to go by what's down here, x plus 5 and x plus 4. Sorry, I'm having to squeeze that in. I got to make it fit on the paper. I mean, permanent marker on a white table. Come on. All right, and then what was in our numerator now is in the denominator, and that's x minus 5 times x plus 2. All right, so let's take a look at what we've got here. So I've got x minus 5, that's across the top. I want to see if I can match it up with anything on the bottom. I can right here. So when I can match that up, I can cancel those out. All right, then I look for x plus 5. I look across the bottom, look across the bottom. I don't see that. X plus 5, again, I did not see that in the bottom, but x plus 4, I did. That x plus 4, that x plus 4. Okay, so let's take a look at what we've got left. All right, there's still a good deal of things that are here. So starting right here, there's a x plus 5, x plus 5, okay? And that's going to be over our 2x minus 3 and our x plus 2, all right? And do we have anything else that can cancel out between numerator and denominator? No, that is our simplified form of that one. So division is one step more than what our multiplying is, but it still uses the same basic rules. Factor, 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 then cancel out, reduce whatever you can, combine. All right, let's go to the one that's a little bit harder. And all it is that it's got some really deep GCF and Cali method on it, okay? So I want you to let's take a look at the first one. Remember, sorry guys, we're going to have to do that LCR because it is a division problem. And sometimes you guys might want to go ahead and do that first so that you don't get tripped up and you then have to fix it in the middle of it because it might be kind of hard for you to remember that. Okay, so let's go ahead and try that. I'm going to rewrite this now in the LCR form. I'm going to change it from a division to a multiplying problem and then flip this over. All right, so rewriting my problem, back this up a little bit so you guys can see. That's going to be that it's 2x squared minus the 7x. And I can already identify that I'm going to have to do Cali method on this so that I can factor that. That's going to be over my x squared minus 9. I can recognize this is the difference of perfect squares, so I'm going to use that when I factor that. All right, and now it's going to multiply, not divide. And now I've got to flip this over. So instead of 4x squared minus 1 on the numerator, I'm going to put 8x squared minus 28x plus 12. Now, I'm looking, I see that starts with an 8. 8 won't evenly factor out of those, but 2 and 4 will. 4 is the bigger of those two numbers. So I'm going to use 4 when I go to start doing my factor on this one. So it has a GCF. All right. And that's going to be over 4x squared minus 1. 4 is a perfect square number. X squared is a perfect square. And 1 is a perfect square. So I'll be using the difference of perfect squares with this as well. Okay. All right, so I took a moment here to go ahead and set up my Cali method. All right, so 2 times the negative 4 gives me negative 8. It's a negative, so I'm going to have a positive and a negative that are multiplying together. And I noticed that the first set, 1 and 8, would give me a difference of 7. And if I made that 8 be negative, it would be a negative 7. Okay, so that works out. So that gives me the AX term, 2x over the 1, and then 2x over that negative 8. Now, 2x over negative 8 will reduce to x over negative 4. So the factors that we have of 2x squared minus 7x minus 4 are 2x plus 1 and then x minus 4. Okay? All right, and then the difference of perfect squares, that's going to be x minus 3 and x plus 3. Now remember, this is multiplying, so it's really all just combined across the top and across the bottom. So I'm going to go ahead and start working on this now. Now, This is going to take a little bit of work for me, so I just want to show you guys. I'm going to go ahead and do the GCF of that 4, pull that out to the front. So when you divide out 4 from all of your terms, divide that 8 by 4 and you're going to be left with 2, and then that's x squared. Negative 28 divided by 4 gives you negative 7x, all right? And then positive 12 divided by 4 gives you positive 3. Now we'll do our Cali method with this. Ooh, sorry, guys. All right, and we're going to have that it's 2 times the 3. That gives us a 6. Well, we need it to be that it's 2 negatives because this is negative here, but everything else is positive. So if we make it 2 negatives, we know if we do negative 1, negative 6, add those together, it gives us negative 7. Okay, so your AX value over your first factor, and then your AX value over the second factor, and we know this 2x over negative 6 is going to reduce. So take a look. 2x over negative 6 is going to reduce to give me x over negative 3. All right, so the factors that we have of the numerator now are 2x minus 1 and just about to run out of line here, x minus 3. All right, I know you guys are getting excited. You kind of see where we can start really crossing some things out, but hold on just a minute. Let's take a look. We've got this last denominator here. I need to factor that. Now remember, 4 is a perfect square number. 1 is a perfect square number. 4 is a perfect square of 2. That's like 2 that's being squared, okay? And 1 is the perfect square of 1. That's like 1 being squared. Then we do the difference of it, okay? So 2x minus 1 and 2x plus 1. All right, so here we go. This is what you guys have been waiting for. Take a look at it. Start with the top, 2x plus 1. Well, we just did that. Boom. Boom, done, canceled out. X minus 4, do we have any x minus 4 in the bottom? No, leave it alone. Okay, I'm going to circle that. That means that's going to be there when I get through. 2x minus 1, if I take a look, is right over that. I go ahead and cancel those out. And then x minus 3, there's an x minus 3 right here. So I'm going to cancel those out. And I have this is left in the bottom. So let's take a look. X minus 4 over x plus 3. Those will not reduce each other. So this is as simplified now as it will go. It did take a little bit of work. I mean, look at that. But it's using every skill that we have learned, and you guys totally have this. All right, in the next videos, you will see that we're going to be doing some adding and subtracting. And remember, we have to have a least common denominator. So make sure you're mentally prepared. Have that time that you set for yourself so that you can work on learning these skills. Remember, hit me up in email or on Remind if you've got any questions. Good luck, you guys.